So here's a demonstration to challenge your understanding of centripetal force versus centrifugal force. So we can see there's this spherical shape here made out of two circular rings. And when I turn the handle, we watch it spin. I want you to notice what happens to the shape of this object. You see it? Looks like it compresses into this shape as long as it's spinning. So does that mean there was a force pushing to the outside? And when things spin, then there happens to be a centrifugal force? So I challenge you to think of it in a different way. All right, so we mark a little segment of it with a piece of tape. Think about this. Notice what happens when I push it down into this shape and let it go. If it's deformed into this shape, then there's a force pushing this segment to the inside. We can see that because when I let go, that's the direction that it moves. So right now, if there's no tangential velocity, then there's no need to have a centripetal force. But if every part of it moves, every bit, every segment has a tangential velocity. And so the law of inertia says this segment would like to continue going in a straight line. But it won't go in a straight line as long as something can provide a force centripetally toward the inside. And so it's its desire to travel in a straight line. It's that inertia that puts it out of round. And now that it is out of round, that tension that appears pulls it to the inside as long as it's spinning. So indeed, anytime an object is moving in a circular path, there must be centripetal forces acting on it. And any notion you have that there might be centrifugal force is probably a misconception of the concept of inertia along the tangential path.